God, quantum computing is going to be paradigm shifting. I mean, it is going to change the way that we tackle precision therapy. It's going to enhance our diagnostics. It's going to change the way that we model our natural systems and simulate our natural systems in a time of climate change, right? It's going to change the way that we design drugs, and also accelerate already advanced technologies like artificial intelligence, right? And between that and the precision therapy is a heavy place where Ingenii is playing right now. But I mean, quantum computing, the use cases are endless, but it is paradigm shifting, right? And when we think about the timelines, it's not as far out as most people think. I think a lot of people think that, it's like 5-10 years down the line, but it's not a big bang approach. It's very much a stepping stone approach. And there's very clever hybrid solutions already out there, some of which we're developing. There's fully quantum solutions that only require, 10, 15, 20 qubits, right? Which is all available on the quantum cloud, within the quantum cloud services, right? So there's power that can be unlocked today, right? But the biggest gap is the wider kind of research, data science, computational science community. They don't have deep quantum physics backgrounds, right? Like, this isn't like just picking up a new type of software. Most of these researchers and scientists don't have this deep quantum physics expertise, right? So that means they're going to be heavily reliant on vendors and outsourcing that, or there's going to be a pretty hefty path up to upskilling. And a lot of organizations actually already believe that they're just going to upskill their existing data science teams, right? And so I think it's being overlooked what that truly means, right? It's a whole different type of physics, totally different laws of physics, totally different way of framing the problem, and that's the biggest gap that we at Ingenii see, right? We see all of these incredible researchers and scientists racing towards some of these amazing innovations, and we see quantum being able to unlock some of these amazing innovations, right? But bridging that skill set, and making sure that they have the tools that are usable to adopt it in a wider scale, right? That's where we're coming in, right? And we're doing that through building out our quantum algorithm library that's really designed for the non-quantum physicists. So we're handling all of the heavy lifting of the quantum development, all of the quantum, gate and circuit configuration, right? The error mitigation. We're handling all of that heavy lifting so that the data scientists out there and the machine learning engineers out there can pick these models up, test and play around with them, and not have to waste all of their time learning quantum physics, right? They can unlock the power of quantum without having to, go deep in that knowledge. So, that's really what we're looking to build. And we pair our quantum algorithm library with our data engineering automation. So we're very much about integrating into the classical cloud stack. Quantum is an augmentation, not a rip and replace of classical computing. And we feel that the integration is super important to really optimize, what you can really do with it across your organization. Our background, actually, our leadership background is heavy in cloud and data infrastructure. And so quantum was that next evolution of data analytics, and is going to be a powerful one. So we know that space really well. And then our chief science officer, Laya, goes really deep with quantum machine learning. And so together, we're really able to kind of bring together a solution for, those that don't go deep with the quantum physics knowledge. And we're hoping that by doing this, that, when we talk about all these transformational use cases, that we're going to accelerate those to market. That's how we view our role in this, as a facilitator. We really want to make sure that the tools are ready in time, to be able to unlock the power as quickly as we can, as the hardware, allows us to. So that's the mission we're on. If you like us, if you want to join us, we've got a developer community we're building out. And then we've also got, our end user community. If you don't have that quantum physics background, you can also just sign up as a as an end user and either use the models that we have available today or keep your eye out as we continue to develop. There might be one that comes in that's relevant to you. We also have links on the website to provide feedback if there's models that you want us to consider, prioritize. Don't be shy. Please submit them. We want to hear from you. We want to work with you. We want to build with you. And we really want to have an impact with the technology that we're building. So that's a little bit more about our story and our mission. Thanks for listening.